Okay, good evening. Welcome to
FamilyMath number 781.
Math781. So this is a problem that came in your geometry book yesterday. It gave you some trouble. Do you remember this problem?
Yeah, I do.
Okay, we talked about it yesterday. Before we talk about it now, can you tell me some of the things you were trying, or do you remember some of the things that were giving you trouble or why you were stuck on this problem?
Well, what I was trying to do, I was trying to do equations for each of the triangles, so I was looking at the hypotenuse as square root of h plus x and h plus y, and then square root of h plus x, and then I tried to put them together in an equation. And
okay, hold on. Let's write those lengths a little bit bigger so you can see them now. But also, it's not the square root of y plus h.
so h squared plus x squared.
There you go.
So x squared. So I tried to put these together in an equation and tried to get this as a result, but I could not figure out how.
Okay. That's actually a really interesting way to approach this problem. So you know this is the hypotenuse.
Yep.
So it's the square root of y squared plus h squared. And you know this is a hypotenuse of a right triangle. And you know, therefore, it's the square root of h squared plus x squared.
Yep.
And then, what would you like to do to complete that argument?
Well,
You don't have to do it. In fact, we'll do it in the next video. But what would you like to do? What would your goal be?
well, you could try to get rid of try to get the h on this side, and then just try to get rid of all the h squareds in the square roots, and then simplify these down.
Okay. Yeah.
Those.
The square roots are a little tricky, but you're right. Maybe there's a way to do that.
Yeah.
Okay. Yeah. I didn't actually realize that's what got you stuck yesterday. That's great. And we'll talk about it. We'll talk about that in the next video. Okay.
Okay.
And this is kind of an algebraic way of solving this problem. And what ideas are you using here?
Well, the Pythagorean theorem to find this hypotenuse is, and then so I'm solving the equations
Okay.
and trying to simplify it.
All right. But it turns out there's a different idea you can use here. And what is that idea?
Similar triangles.
Okay, how does that work? Let me just erase these square roots just to get them out of the way. How does the similar triangles approach work?
So you have you have three right triangles, and so you have three right triangles. You have this one, and the big one.
Okay.
So first you want to, you notice that you see two angles a lot. You see there's this angle and this angle that you see a lot in these triangles. So from this you know that they all are similar.
Okay.
So let's see. So then, let's see. So then, well, you know the sides are. I don't really remember all of it, but maybe you could try to put together these hypotenuses on y plus x, and then use the other hypotenuses too.
Well, if you know the triangles are similar, just knowing this triangle is similar to this triangle is actually going to be enough to help you with that. So what does it mean when triangles are similar?
Their sides are in same ratio, and their angles are the same.
Okay.
So, yeah, their sides are in the same ratio. So you could look at where this square root of x times y comes from. So if you know they're all in the same ratio, then the Pythagorean triple that has them will be in the same ratio too.
Okay.
Seeing how this could.
Well, what sides do you think are going to be in the same ratio as each other?
Well, you have H is the side going up here, and that side on the big triangle is here, but it's also on this medium triangle, is this side here. So that would, H and X are in the same ratio as Y to H.
Okay, so why don't you write that down?
So H equals Y over H.
All right.
So first thing you would want to do is,
H over X equals, is that a Y?
oh, yeah, it's a Y. So you could multiply by X to get rid of the X and H to get rid of the fractions.
Okay.
So you get H squared is YX, and H equals square root of XY.
All right.
And that's the equation you want.
Nice. Cool. All right. That's interesting. It's just a ratio problem with similar triangles.
Yep.
All right. Good work. Now let's take a look at your way.